Howdy, howdy, this is Mr. Potter. In today's episode, we're going to do an introduction to two different types of programming. One is turtle programming, and the other is Python programming. And so I want to talk a little bit about what turtle programming is, and I want to talk about a little bit about Python programming. And the fact that they're both named after animals is completely a coincidence. So the first thing we're going to do is we're going to go to this website. It's sculpt.org, skulpt.org. And this is going to be the interface where we're going to be doing our programming. So I'm going to go ahead and show the screen. Here we are. So the first thing I want to talk about is turtle programming. And the idea behind turtle programming is that we're going to have a turtle on the screen that we're going to direct around the screen. So we're going to give the turtle directions like move forward, or we're going to give the directions like move left. We're going to tell it to move a certain number of distance in pixels, a certain number of degrees. And so we have a turtle object that we're manipulating. We're doing Python programming because Python is the name of the computer language that's implementing it, which is why we have the import statement. So we're actually importing a turtle. And we have this for in, and then we have this list. And we just finished talking about lists. So this is going to be one of the first opportunities that we have to really implement lists in computer programs. And so it's a combination of turtle programming in a Python environment. Python is one of many computer languages that implements turtle programming, and Logo was actually one of the first ones in the 1970s. Python's probably the most easiest way to implement it today because Python incorporates the command line with the graphics capability. So I've got some code here, and I want to kind of illustrate what's going on with this code. This first line of code sets up the turtle environment. So the thing is, I'm really doing my turtle math here, my turtle programming, by doing this import turtle. This sets up the turtle environment so that I can create turtle objects and I can manipulate the turtle objects. And by the way, when I put this hashtag in front, this is the way that I comment in Python. The next line of code that I have here is I say t gets turtle.turtle. And what this is doing is it's going to this turtle package and creating a turtle object and calling it t. So this is the name of the variable that we're going to be manipulating in this program. And I'm going into the turtle set of programs, this import turtle that we had, and creating a turtle object. Notice that the import part is lowercase, but the actual object that we're creating, this constructor, is capitalized. So this actually creates a turtle to manipulate. So now I've got my next line here, and it says for C in red, green, yellow, and blue. Now notice that these are all colors, and what they're going to do is they're going to change the color of our turtle. I'm going to be able to do it once for every one of these colors. So as long as C is one of these colors, we're going to create a turtle of that color. So this is the list we are manipulating. And this is the command to change color. So if I want to change color to red or green or yellow or blue or orange or black or white or any color that I want, I just need to put it in quotes. And yes, we do have the ability to create our own colors using those hex colors, those hex codes that we talked about back in Unit 1, where we can talk about the amount of red, the amount of green, and the amount of blue. We'll do that in a later video. The next command we have is forward parentheses 75. We're telling our turtle to move forward 75 pixels. So this moves the turtle forward. And then we have our last command here, which turns the turtle left 90 degrees. So what this is going to do is this turns the turtle left 90 degrees. And by the way, there is a corresponding t.right, which would turn the turtle right a certain number of degrees. So I've explained what each line of this program does. Now I want to talk about what the list itself does. Notice that there are 4 objects in the list. By the way, this is object 0, object 1, object 2, and object 3, and we can refer to these objects later on. But what's going to happen is we're going to choose red. Red is one of the colors in this list. And so C is going to be red. We're going to create a turtle of color C. We're going to make it move forward 75 pixels. And then we're going to make the turtle turn left 90 degrees. And then we grab the next color. So now we change our turtle's color to green. It still goes forward 75 pixels. It turns left 90 degrees. And we grab the next color. We're going to do that for every one of these colors. Every one of these colors is going to be represented by a turtle that moved 75 pixels forward and turned left 90 degrees. And it's going to do it in this order: red, followed by green, followed by yellow, followed by blue. And I'm going to scroll down here and hit the run button so that you can see there's the red, then the green, then the yellow, then the blue. Notice what happened. We went 75 pixels forward, and then the turtle turned left, and then we got the next color, which is green. We changed our turtle to green, went forward 75, and that's why this path is green. And then we turned 90 degrees. We grabbed the next color, which is yellow. We went forward 75 pixels, which is why we've got this yellow stripe here. And then we turned left 90 degrees, grabbed the color blue, and finished it. So it's going to do one of each of these steps for every color in this list. And what this allows us to do is, because we have a list, we can actually change these to different items. So what I'm going to do is I'm actually going to change this so that it is orange all the time. And what I'm going to do instead is call this, instead of C, I'm going to call it dist to represent a distance. And instead of these being text, I'm going to make these be numbers, like 60, 100, 130, 180. And so for this forward, instead of always moving forward 75, we're going to move forward whatever the variable dist has to say, which means my first orange segment will be 60 pixels long. My next orange segment will be 100 pixels long, then 130 pixels, then 180 pixels, which means I'm going to start off with short segments, and this thing's going to get longer and longer. And it makes a rather interesting shape. So there's my orange, and it's a little bit longer, and a little bit longer, and a little bit longer. You can see I've got the start of this spiral. If I wanted to make the gap between the numbers smaller, I could actually put more numbers here. So 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. I could try this, just put a whole bunch of numbers in here, because remember, we can add elements to a list. That was one of the things we saw back in Unit 3. We could do the append to add things to the end of a list, and we also saw that for the insertion sort, we actually wanted to add our new data elements to the end of a list. But with what I've got here, it's going to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different parts of this spiral. And so you'll see the 60, 70, 80, 90, 100, 10, 20, 30, 140, and 150. And I can keep on going with that list if I wanted to make this a more and more involved spiral. But we've used the list to denote the color. We've used the list to denote the distance. We could also use the list to denote an angle. And so instead of having the distance be variable, we could have the angle be variable. And this is interesting because I'm going to start with a 60-degree angle, then a 70-degree angle, then an 80-degree angle. Let's see what this looks like. There's my 60-degree angle, 70, 80, 90, 100, 10, 20, 130, 140, 150. And notice every time it's turning more degrees, so it's making a tighter angle. Notice that we had a straight line here, but it turned over 60 degrees to get to the second segment. And now the straight line we turned that. So the thing is, geometrically, this looks like a 120-degree angle because we're really talking about the linear pair being 60 degrees, or the linear pair being 70 degrees. But this just kind of denotes how we could use the list to kind of tweak this around. And what we're going to learn about later is how we could use even more of these lists together. Maybe we could use two lists at the same time to change the distance and the angle at the same time. So one thing that I want to do last, I'm going to go ahead and change this back to the colors that we had. So let's go ahead and say red, orange, yellow, green, blue, and violet. And notice that if I want to put it as a text, as a string, I need to put it within these single quotes. So again, this is going to be my colors. And so I want my color to actually be this variable color. If I wanted to make a hexagon, remember a hexagon has 6 sides. So I need to figure out, okay, how far forward do I want to work? And 75 seems like a reasonable amount. It seems like we were starting with a hexagon before the angles got all crazy here. And if I wanted a hexagon, keep in mind that if I want a straight line is 180 degrees, I want to turn 60 degrees every time. So I can do that. And if I run this, then there's my red, my orange, my yellow, my green, my blue, and my violet. So I've got a hexagon here. If I wanted to make a more, a different type of polygon, all I really need to do is remember that I'm going to take this angle, and it's really going to be 360 degrees divided by the number of sides. That's what we learned in our geometry class. A square, 360 divided by 4 gave us 90 degrees. If I wanted to deal with a pentagon, I'd have to take 360 and divide by 5, which actually gives us 72 degrees. And if I run that, you'll see that I actually end up with a pentagon. It just traces over that last side. And if I wanted to make this 45 degrees, then that actually would get us the start of an octagon. But of course, because I'm only doing 6 sides, because I only have 6 elements in my list, it's not going to make the full octagon. I need to add some other things in here like purple and black. And by the way, notice that as I type and stuff scrolls off the side of the screen, we could use the scroll bar to get the rest of it. Let's see if this actually gives us different colors. 4, 5, 6, 7, 8. Notice the purple and violet are indeed different colors. So what we're doing here in this Python environment, we're using the Python computer language to learn about turtle graphics. The idea that I could take a turtle and I can tell it to do things. I can tell my turtle to change its color, and we change the color to lots of different colors in this program. I can tell the turtle to move a predetermined number of pixels forward, and I can also tell my turtle to move left or right depending on the situation. So what we're going to do in future episodes in this unit is we're going to talk about more things that we can do with this turtle, more patterns, more procedures, and really whatever gives us the control to do what we need to